Now we see the last part of the topic, revisiting rational numbers and their decimal expansions. Before we move to the exercise, you have to see three theorems. Those three theorems will help you to solve the sums. Theorem 1.5. Let x be a rational number whose decimal expansion terminates. Meaning of terminates means, in a very simple word, when we divide and when remainder comes 0, then it is called as terminates. Then x can be expressed in the form p upon q, where p and q are co-primes and the prime factorization of q is of the form 2 raised to n into 5 raised to n, where n and m are non-negative integers. Theorem 1.6. Let x is equal to p upon q be a rational number. Rational number means numerator upon denominator, such that prime factorization of q is of the form 2 raised to n into 5 raised to n, where n and m are non-negative integers. Then x has decimal expansion which terminates. The next theorem is theorem 1.7. Let's see what the theorem says. Let x is equal to p upon q be a rational number such that the prime factorization of q is not of the form 2 raised to n into 5 raised to n, where n, m are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating. Repeating means recurring. Okay, so these three theorems which we have seen, okay, they are useful here in solving these sums. The first question, okay, is of this exercise is, that is exercise 1.4. This is exercise 1.4. Without actually performing the long division, we don't have to perform the long division here to show whether these are terminating or non-terminating decimal expansions. State whether the following rational numbers have a terminating decimal expansion or a non-terminating decimal expansion. First I will solve these three sums. I will solve one after the other. First here, that is 13 upon 3125 is equal to, I will write here, is equal to 13 upon, what we have to do in such case, when we have to decide whether it is terminating decimal expansion or not, find the prime factors of the denominator. I will find here the prime factors of the denominator. 3125. We can do it in rough column also. 5, 6 are 30, 1 is left. 1 and 2, 12. 5 2s are 12. 10, 2 is left. 5 5s are. Then this is 5. 125 are. 5 25 are. 5 5s are. 5 1s are. I'll write here. It is 1 2 3 4 5. 5 raised to 5. But what we have to do? We have to see that denominator is of the form 2 raised to n into 5 raised to n. Then what I will do here? 13 upon, here it is 5 raised to 5. If I want to write in the terms of 2 raised to n into 5 raised to n, I have got, okay, 5 raised to 5. What I will do? I will write here 2 raised to 5. Right? Then it becomes 2 raised to n into 5 raised to m. Then into this denominator I will take here. Actually 2 raised to 5 and 2 raised to 5 gets cancelled. But as we have to show whether it is a terminating decimal expansion or not, if it is 5 raised to 5, this will be okay, 2 raised to 5, and 2 raised to 5 will go in the numerator, because if it is a terminating decimal expansion, either all the factors should be of 5 or all the factors should be of 2, or it should be a mixture of 2 and 5 in the denominator. Here we have seen all the factors are of 5, but as we have write in the terms of 2 raised to n into 5 raised to m, I will write here 2 raised to 5. Why? Because the degree of 5 is 5. Same 2 raised to 5 I'll write in the numerator. Actually it gets cancelled, but we have to write to show in the terms of 2 raised to n into 5 raised to n. Then after finding the factors and after writing this, I will write here as the denominator is of the form 2 raised to n into 5 raised to n. Therefore, I will write the original number 13 upon 3125 is a terminating decimal expansion. Because theorem says that it should be of the form 2 raised to n into 5 raised to n, where m and n are non-negative integers. So here the first example is a terminating decimal expansion. Let's see the second example. 17 upon 8. There it is. 64 upon 4. 55. I kept this. 17 upon 8. Same method. We have to find the factors of the denominator. Second is, okay, this is second sum. 17 upon 8. 17 upon 8 means what? 2 into 2 into 2 is equal to 17 upon 2 raised to 3. But denominator, yes, as I said, either all the factors should be of 2 or they should be of 5 or the mixture of 2 and 5. Then only the fraction is a terminating decimal expansion. Here the factors are of 2, but we have tried in the terms of 2 raised to n into 5 raised to n. So this becomes 17 upon 2 raised to 3 into 5 raised to 3. 5 raised to 3 will come in the numerator because this gets cancelled. But the reason we are writing is okay. We have to show the denominator in the terms of 2 raised to n into 5 raised to n. Okay, then I'll write here as the denominator is of the form 2 raised to n into 5 raised to n. Therefore, 17 upon 8 is a terminating decimal expansion. Terminating decimal expansion. Third sum. Is it clear? I will write the third sum. Third sum is 64 upon 455. Let's see the factors of the denominator. If number is big, it's better you find the factors. 455. This is 5 9s are, 5 1s are. This is 13 7s are, 7 1s are. But if you look at the factors, one factor is 5, but other factors are okay. They are not 5 or it is not 2 also. All the factors should be of 5 or all the factors should be of 2 or the mixture of 2 and 5. If any other number comes other than 2 and 5, then it is not a terminating decimal expansion. I will write here is equal to 64 upon 5 into 13 into 7 as the denominator is not of the form. Which form? 2 raised to n into 5 raised to m. Therefore 64 upon, it is 455 is not a terminating decimal expansion. Okay, now we'll see the fourth sum. 4 sum 15 upon 1600. 15 upon 1600. Find the factors of 1600. 2 800s are 2 400s are 2 200s are 2 hundreds are 2 50s are 2 25s are 5 5s are 5 ones are. So look at the factors. All the factors are of 2 and 5. They are the mixtures. Mixtures okay are still okay. 5 is equal to, this becomes 15 upon 1, 2, 3, 4, 5, 6. This is 2 raised to 6 into 5 raised to 2. See here. 2 are how many times? 1, 2, 3, 4, 5, 6. So 2 raised to 6. And 5 are how many times? 2. 5 raised to 2. Is the denominator of the form 2 raised to n into 5 raised to n? Yes. As the denominator is of the form 2 raised to n into 5 raised to n, therefore original number 15 upon 1600 is a terminating decimal expansion. Next sum 29 upon 343, that is fifth sum. 29 upon 343. Let's find the factors of 343. 343. So this is 7 4s are, yes, 7 4s are 28. 34 minus 28 is 6. 63. 7 9s are. This is 7 7s are. 7 1s are. If you want to check, you can check it here. 343 divided by 7, right? 7 4s are 28. 63. 7 9s are 63. What is the remainder? Is it? So that you have to check. Is equal to 29 upon 343 is equal to 29 upon 7 cube. Here the denominator is not of the form 2 raised to n into 5 raised to n. So I'll write here as the denominator is not of the form 2 raised to n into 5 raised to n. Therefore 29 upon 343 is not a terminating decimal expansion. Denominator has to be of the form 2 raised to n into 5 raised to n. Then only this given fraction is a terminating decimal expansion. Otherwise, it is a non-terminating decimal expansion. We'll go on the next one. That is sixth one. Sixth is what? 23 upon 2 raised to 3 into 5 raised to 2. But see the sum. It is already factorized. It is in the form of 2 raised to n into 5 raised to n. So we don't have to do anything. We have to see the denominator, and that will tell us whether it is a terminating decimal expansion or not. I'll write here as the denominator is of the form 2 raised to n into 5 raised to m. Therefore 23 upon 2 raised to 3 into 5 raised to 2 is a terminating decimal expansion. Because we don't have to factorize here. Denominator is always in the form 2 raised to n into 5 raised to m. The next sum, 7th sum. 7th I will write here. This is 7th sum is 129 upon 2 raised to 2 into 5 raised to 7 into 7 raised to 5. Here also if you see, denominator is already factorized. But see, 2 raised to 2 is here, into 5 raised to 7 is there, but 7 raised to 5 is there, other than 2 raised to n into 5 raised to m. So we don't want any other number other than 5 and 2. So here as 7 is there in the denominator with 2 and 5, the fraction is a non-terminating decimal expansion. I'll write here as the denominator is not of the form 2 raised to n into 5 raised to m. Therefore, 129 upon 2 raised to 2 into 5 raised to 7 into 7 raised to 5 is not a terminating decimal expansion, right? Because denominator should be of the form 2 raised to n into 5 raised to m. Now I'll go on the 8th sum. 8th sum is 6 upon 15. I'll write 6 upon 15. 2 into 3 upon, this is 5 into 3. This 3 and 3 gets cancelled. What is left? 2 upon 5. Is the factor, one of the factor 5? Yes. So means it is a terminating decimal expansion. But then I have to write, okay, like this, is equal to 2 upon 5 raised to 1 into 2 raised to 0. Here also 2 raised to 0. Because 2 raised to 0 means 1. The identity in laws of exponent is a raised to 0 is equal to 1. Similarly, it becomes 2 raised to 0. That will be 1. And 5 ones will be 5. So I will write here as denominator is of the form 2 raised to n into 5 raised to n. Therefore, I'll write here. Therefore, 6 upon 15 is a terminating decimal expansion. Terminating decimal expansion. Right? Now you go on the 9th sum. What is the 9th sum? 35 upon 50. I will write 35 upon 50. 2 into 5, 10. 10 5s are 50. Is the denominator of the form 2 raised to n into 5 raised to n? Yes. Is equal to 35 upon 2 raised to 1 into, this is what? 5 square. Clear? Therefore, okay? Or instead of writing therefore, I will write okay. As denominator is of the form 2 raised to n into 5 raised to n. Therefore, 35 upon 50 is a terminating decimal expansion. It is very easy, okay? If it is asked, they may ask you in section B or even in section A in terms of MCQs. The last sum, 77 upon 210. There also we will see what are the factors. This is the 10th sum, 77 upon 210. I'll find the factors. 210, 2, 10, 5s are 5, 21s are 3, 7s are 7, 1s are. Let's again see. 105 into 2 is 210. If you divide 105 by 5, 5 2s are 10, 5 1s are 5, 3 7s are. So what is left? 77 upon 2 into 5 into 3 into 7. Look at the denominator. Is it of the form 2 raised to n into 5 raised to n? No. Because there are other factors other than 2 and 5. Then I'll write here. As the denominator is not of the form 2 raised to n into 5 raised to n. Therefore 77 upon 210 is not a terminating decimal expansion. So here all the 10 sums have got over in the first question. So this is the way, okay, to check whether the fraction is a terminating decimal expansion or not. We'll see the second question, okay.